Number system 7, using properties of exponents. The learning target we're looking at today is I can use properties of integers, exponents, to simplify expressions. So we're not going to evaluate them, which means to solve them. We're just going to simplify them. And the two we're looking at today has to do with multiplication and division. So let's get started. If you are multiplying numbers in exponential form with the same base than you. So let's look at examples. As we talk through it at the end, you'll be able to come up with a statement to finish that sentence. So the multiplication of exponent form. So let's go x to the 5th, and we're going to multiply that times x to the 2nd. So to help you understand this, we're going to write it out in expanded form. So x to the 5th would be x times x times x times x times x. 5 x's, all being multiplied by themselves. X to the 2nd, or x squared, would be x times x. So now when I look at that, noticing with the same base, I could put all those together in a simplified version. So I can have these 5x and these 2x and put them together to make 7x's. So notice we started with this problem. They were being multiplied, or the product of these two is x to the 7th. Let's check another one. Let's go y to the 3rd times y to the 4th. Okay, we're going to write them in expanded form so you can look at them. So this first one here would be 3y's being multiplied by themselves. The second one here would be 4y's multiplied by themselves. And when you look at that, I have 3y's, I have 4y's. That means in the end I have 7y's. So kind of if we start looking at some simplifying ideas, notice when we write them in expanded form, we're just going to add up the number of y's in each of those expanded forms. So there's 3y's here, there are 4y's here, and we end up with 7y's. So it looks like we're just going to add the exponents. Let's look at another example. What if we have x to the 5th times x to the 6th? Well, this time I'm just going to think about it before I write that all out. So I have x to the 5th. That means I have 5 x's. I have x to the 6th, which means I have 6 x's. Well, if I have 5 x's and 6 x's, when I add those together, I would definitely have x to the 11th. Okay. Let's look at a little bit more complicated problems. So let's look at one that has 3. So let's say we have m to the 4th times m to the 5th times m to just to the 2nd. Okay, so we'll go through this. I have m to the 4th, which means I have 4 m's. I have m to the 5th, which means I have 5 m's. I have m to the 2nd, which means I have 2 m's. Well, if I add those up, 4 plus 5 plus 2 would equal m to the 11th. Next type. Okay. Let's make it have a coefficient. So let's say we have 2x to the 8th times 4x to the 5th. Okay, now this is something different, so pay attention. Notice we have now what we call coefficients, and coefficients are just the value in front of an exponent. It's being multiplied times that exponent. So we're not going to change what we mathematically know what to do. If we were to ignore, so not paying attention to my exponent, if I was just looking at this and I see 2 times 4, that's what I'm going to do mathematically. So 2 times 4 is 8. And now I'm going to pay attention to my exponents. I have x to the 8th, which means I have 8 of them. I have x to the 5th, which means I have 5 of them. So I have 8 plus 5. And if I put those together to simplify it to our lowest terms, I have 8x. And I'm going to add 8 plus 5, which is 13. And that's as simple as it gets. Next problem. Let's go 5y to the 10th times 5y to the 10th. We'll just multiply the same thing. So again, ignoring the exponents or the exponential form and just looking at what we call the coefficients here, 5 times 5, don't change what you've learned before, is 25. Now we look at the exponents. We have y to the 10th times y to the 10th. So that would be 10y's here plus 10y's here, and that would equal 25y to the 20th. Okay, last couple examples. Let's look at 3x to the 4th, y to the 7th times 4x to the 5th, y to the 11th. Okay, this time I added 2 exponents, and that doesn't make any difference. Just because there's an x and a y, that doesn't mean that we're going to change our ideas. So you're just going to walk through the steps. It takes one extra step, but it's going to be the same thing. So again, we're just going to not change what we know what to do with the coefficients. I'm going to take 3 times 4, which is 12. Woo. And then we're going to mess with the x's. So we have 4 x's here and 5 x's here. So 4 plus 5. And then we're going to look at your y's. We have 7 here and 11 here. So 7 plus the 11. And we're going to simplify this all the way down into, well, we have 12 as the coefficient. We have 9 x's. And we look at this, and now we have 18 y's. Okay. We're going to do one more example with those coefficients. So we have 11. We'll say x to the 3rd, y to the 1st. So it'd just be y, and z to the 4th. Z to the 4th. We're going to multiply that times 3x to the 7th, y to the 3rd, and z to the 8th. I have no idea why that flings over there, so I apologize. All right, again, coefficients. We're just going to multiply like we always have. That's 11 times 3 is 33. Now we're going to mess with the x's. We have 3 x's here, 7 x's here. We have 3 plus 7. Now the y's. We had 1 y here. We have 3 y's here. So 1 plus 3. I'm going to run out of room, so let's see if I can sneak this. We'll just do it down here. Z. I have 4 z's here and 8 z's here, so 4 plus 8. And we're going to put this all together. So again, the coefficient is 33. We just keep putting that in the front. X, we're going to look at addition. We had 3 and we had 7, so now we have 10. Y, we had 1 and 3, so now we have 4. And Z, we had 4 and 8, now we have 12. So looking at multiplication, hopefully that helps you. So remember, we're going to go back to that beginning question. If you're multiplying numbers in exponential form with the same base, then you, and I just gave you lots of examples, so you should be able to answer that on your paper. Now we're going to look at division. So just changing a little bit. So instead of multiplying, we're going to divide. So kind of think about that. That's the inverse or the opposite. So see if how that works when we're simplifying. Again, an exponential, and it has to have the same base. So we're going to start with, let's go with x to the 2nd times x, I'm sorry, that would be x to the 8th divided by x to the 2nd. So I'm going to write this out till we get used to what we're doing. So we're going to write this out in expanded form. So I got 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to divide that by 2 x's. So if we're taking 8 x's divided by 2 x's, and I think about math in our division idea, so if like, for example, if I had 2 over 2, and if I was actually dividing that, we know that becomes 1. Okay, if I had 2 times 2 over 2 times 2, again, that would be 1 because 2 divided by 2 is 1, and 2 divided by 2 is 1, and 1 times 1 is 1. So I can use that same idea just with variables. I have x divided by x, which becomes 1. I have x divided by x, which also becomes 1. So if I have 1 times 1 times 1 times x, well, that's just still going to be x because anything times 1 is that same value. So in this case, it's just an x. So what do I have left? Well, it looks like I have 6 x's in the top, and I have no x's in the bottom. So this simplifies to x to the 6th. Okay, let's look at another example. Oops. Let's just go with y to the 12th divided by y to the 8th. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8, oops, 8, 8, 9, 10, 11, 12. That's a lot of y's. Divided by 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's start thinking multiplication here. Or, I'm sorry, division. So y divided by y is 1. Y divided by y is 1. Divided by y, 1. Y divided by y is 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 1. So I have now 8 y's over y that became 1. So 1 times 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 y becomes y. So in other words, I can kind of just ignore all these ones because again, 1 times something is going to be that same value. So y times 1 is y. So I look quickly and I see, oh, I have 4 y's. So this simplifies to y to the 4th. So mathematically, hopefully you're noticing, you are subtracting the same amount of y's you can have. So since you had 12 y's and now you have, and you subtracted 8 y's because those all became the values of 1, you only are left with 8. So another example, let's say you have y to the 12th divided by y to the 7th. I'm sorry, those are x's. So if I'm not going to write those all out this time. I have 12 of them on the top, 7 of them on the bottom, which means I'm going to cross out or subtract 7 of them, which would leave me with 4 of them left in the numerator. And we can look at the math like that. I'll back this up a little bit. It's 12 minus 7 equals 4. Notice this is totally the opposite operation we did before. When we multiplied, we added those exponents. Now when we're dividing, notice we're subtracting them because we're just pairing up the same ones, which means that we're taking away some of those extra variables. Okay, example would be, let's go z to the 10th over z to the 5th. So that means I'd have 10 z's in the top. I would have 5 z's on the bottom, which means we have 5 pairs of z's that would match up and become 1, which then means that we would have 5 z's left at the top. Because mathematically, we are doing, put this in parentheses, 10 minus 5, and that equals that 5 z's. Okay, we're going to add some coefficients. So let's say we had 15 x to the 10th, y to the 7th, and we're going to divide that by 5 x to the 5th, y to the 5th. So just as we talked before, coefficients are just numbers. Please don't try to do anything funky with them. Just do what you've learned. So since this is division, or you can look at it as a fraction, 15 fifths or 15 divided by 5, that equals 3. And then we're going to look at these x values. So we have x to the 10th divided by x to the 5th. So we know that we're going to subtract those exponents because we have 10 on the top, 5 in the bottom. We're going to pair up 5, which will leave us with 10 minus 5. And then we're going to look at the y's. We have 7 on the top, and we're going to take away the 5 on the bottom. So it's going to be 7 minus 5, and we're going to simplify that all the way down to 3x. Do the subtraction. We get to the 5th power. Y, 7 minus 5 is 2, and I have simplified it down. And we'll look one more like that. Let's go 20x to the 11th, y to the 12th. We'll throw a z in there. Z to the 14th. Divided by 4x. And then we'll go y to the 2nd and z to the 5th. Okay, so let's go through our coefficients. So treat coefficients as coefficients, or numbers as numbers there. So 20/4, or 20 divided by 4 is 5. Now we're going to look at our x's. We have 11 x's on top, and we have 1 x on the bottom. So make sure you notice that since there isn't an x, but there's just one of them. And I can put a 1 there if it helps you. So 11 on top, 1 on the bottom. So we're going to subtract those two. Okay, then we're going to look at our y's. We have 12 on the top, 2 on the bottom. That means we're going to get rid of 2 pairs. And then the z's. We have 14 on the top, 5 on the bottom, which means we're going to get rid of 5 pairs. And we'll simplify. So the coefficient's 5. We're just going to leave that in front. 11 minus the 1 pair, that is the same, makes us 10. Y, 12 minus 2 is 10. And then z, 15 minus 5 is 9. That's as simple as it gets. Okay, one more example. So the last thing we're going to look at is what happens if every time we've done this, we had more of the variable on the top than we have on the bottom. Okay, so let's look at something if, let's go x to the 4th over x to the 6th. Okay, we're going to write this out in expanded form so we can see it first. So x times x times x times x. And now we have x times x times x times x times x times x. More x's on the bottom than the top. We're still going to pair them up and get 1s. So x divided by x is 1, x divided by x is 1, x divided by x is 1, and x divided by x is 1. But notice the x's are now on the bottom. So if I look at my numerator, I have 1 times 1 times 1 times 1. That equals 1. And I have x times x times x times x times x times x. Well, these became 1s. I shouldn't say these are x's. We just have 2 x's left in the bottom. So that's one way to look at it. The other way to look at something like this, and you get to decide which way is easiest for you. Whew, that thing's crazy today. If I just think about subtraction, like we've been doing, if I have 4 and I take away 6, because we know that when we're dividing, we're going to subtract the exponents. Well, that is x to the negative 2nd. And you just did this in Learning Target 1 is when you have negative exponents, what do you do with them? Well, you put a 1 on the top in the numerator, and this becomes positive, but in the denominator. So you can think of it as writing it all out and where the extra x's would be, in this case would be on the bottom, or you can think of it as a subtraction problem like I just did, but you have to deal with what you did in Learning Target 1 and flip that to the bottom and make it x to the 2nd. Notice we have the same answer. Okay, let's look at another one like that. Let's go y to the 20th and then y to the 31st. Okay. So again, I could sit here and write out 20 y's on top, which would take me a long time. We'll pretend that's 20 y's, and 31 y's on the bottom. And then I'm just going to visualize that. Well, if I pair those up, I'm going to pair up 20 y's. That would leave me with no y's left, a bunch of 1's in the top, and that would leave me with the 11 y's in the bottom. Or you can use your subtraction idea. So you have 20 and 31. So I know when I'm dividing, I subtract. So it'd be 20 minus 31. Now, if you do it this way, you have to take the numerator minus the denominator exponent. So that'd be y to the negative 11th. Then you go back to what you learned in LT1. You can't leave it with a negative exponent. So I'm going to put a 1 in the numerator and drop that to the denominator with a positive exponent. Okay, a couple more examples just so you get used to this. Let's say it's x to the third, y to the fourth over x to the eighth, y to the 11th. Okay, so we're just going to deal with the x's for a second. Okay, so you can look at it two ways, and I can do it both ways just so you can kind of decide which way is best for you. You do not have to do both ways, just one. So if I have 3 x's on the top and 8 x's on the bottom, I pair those 3 up, which means I have 5 left in the bottom. Oh, that's not an x. That should be an x. Okay, we'll deal with the y's now. We have 4 y's on the top, 11 y's on the bottom. Pair up my y's, which means I have 7 on the bottom left. And I have a bunch of 1's on the top because of those pairings turn into 1. So that would be my final answer. Okay, look at the other option you have. Put the same problem here. Doesn't matter which way you choose to do it. You do need to show a little bit of work here so we kind of know which way you went. Okay, we're just going to do the subtraction problem. So 3 minus 8, and then y would be 4 minus 11. So 3 minus 8 is negative 5, and 4 minus 11 is negative 7. And then go into your LT1 understandings. Can't have negatives, so we're going to drop both of them to the bottom because they're both negative at this point, and we put the 1 on the top. Okay, last example. Let's say it's 30x y to the 15th over 15x to the 7th y to the 10th. Okay. We're going to kind of combine a lot of things here. So we're going to look at the coefficients. Please just treat them like numbers. So 30 divided by 15 or 30/15 would equal 2. Now we're going to do with our exponents. And it's kind of up to you how you want to start doing this. I'll just go straight up subtraction here. So there's 1 exponent in the top, and we're going to subtract the 7 x's in the bottom. And then we're going to look at the y. And we're treated the same way. So we're going to take 15 y's at the top, and we're going to take away 10 y's at the bottom. Okay, and now we go into simplifying mode. So the 2 stays as 2. We're going to subtract x, and then 1 minus 7 is a negative 6. And then we're going to look at our y's. 15 minus 10 is 5. So now notice this problem, I only have 1 negative. That means I only have to drop this exponent only. That variable and that exponent. Do not drop anything else down to the denominator because that's the only actual negative exponent. So we're going to drop that, put it over here because I'm running out of room. We're going to drop that x to the 6 to the bottom. Now I could put a 1 at the top, and I'm still fine with putting 1 at the top. Well, what's going to happen was when I put that 2, because I still have 2 up in the numerator, because I'd be like 2 over 1 over here, and I still have y to the 5th. Well, what is 2 times 1? 2. So mathematically, we really don't need this 1. In simplified version, we probably shouldn't have that 1. We're just going to take 1 times 2, which is 2. The y to the 5th is in top. The x to the 6th is in the bottom. Ooh, I moved him. And there it is.